Greetings to all. I am Disha Dave, studying at Masters in Construction Engineering and Management program at CEPT University. As a part of semester 2, we have undertaken the studio as construction, project execution, monitoring and control. As a part of studio, a high-rise commercial building is selected. Giving the project brief, the building consists of 3 basements and 20 floors. The start date of construction was August 2022 and it is expected to be completed by March 2024. The built-up area of the project is 5,63,000 square feet. The location of the building is marked in the Gift City Master Plan, and the status of the project when we started our studio was at minus 3 level basement. The following deliverables were conducted as a part of studio. They are pre-construction activities and 2D and 3D site layout visualization. Core planning was conducted in which the major three components, which are formwork, concreting and reinforcement, were studied. Material management and inventory management was done. Also, Primavera software was introduced in which EVM and risk analysis was done. Contract administration was done. Quality management assignments like triple role concept, linear responsibility, quality control laboratory, cost of quality, and tools of quality were undertaken. As a part of the lean construction techniques, three techniques were studied like value stream mapping, foreman delay survey, and mistake proofing. As a part of this portfolio, I am going to mainly focus on pre-construction activities, 2D and 3D site visualization, core planning, inventory management, quality control laboratory, and value stream mapping. Coming on to the pre-construction activities, few things were studied like pre-construction meeting, mobilization schedule, water and electricity requirement at site, legal compliances which are needed, pre-construction and setting up of temporary structures at the site. The site is located in the SEZ zone of Gift City, Gandhinagar. The batching plant is located at a distance of 150 meter in one of the plot. The labor colony is situated outside the SEZ zone of Gift City and it is at a distance of 3.42 kilometer. The water, the source of water at site is from the Gift City Water Infrastructure Limited, and the source of power is from the Gift City Power Plant. The site has availability of water and power throughout the day, and both of them are at a distance of 960 meters from the site. Talking about the labor colony, presently 250 laborers are staying at the labor colony, in which 225 are male and 25 are female. Total of 156 units are there. Each unit is of 3 by 3 meters. The labor colony also has other welfare facilities like basic sanitary spaces and pantry spaces from which the food and everything is arranged for the laborers. The batching plant has majorly two components like quality control laboratory and plant and machinery area. The batching plant capacity is 20 cubic meter per hour. The area of the plot is 2,400 square meter. On-site, on-ground storage for aggregate and sand is sufficient at the area present. The site layout visualization was done in 2D format as well as 3D modeling of site was made in the Revit software. The project status as on 25th February was made, in which all the four floors of basement 3 4 pours of basement 2 and 1 pour of basement 1 was casted, which you can see in the model. The major infrastructures at the site are marked. The vehicular and pedestrian movement is also shown. The site has one major entry from the access road and one rear gate. Site has a ramp through which the transit mixture or any other vehicle can access the excavated area. A self-climbing boom placer is mobilized at the site, which is of a 36-meter boom length. The tower crane is of 50-meter radius. The other site infrastructures can be seen in the site 2D site layout. The major materials of shuttering and reinforcement is stored is and stacked on the ground. The site layout critics majorly were that currently the site doesn't have a female staff toilet, so we have proposed a female staff toilet beside the existing male toilet. There is no security cabin at the rear gate, which increases the chances of unsafe acts. Thus, a security gate is proposed. There is no medical room at the site, so even that is proposed. Also, for the movement of steel, the vehicle gets unloaded as you can see in the 3D model from the front gate. A vehicle comes, unloads the steel and goes back from the same path. For the same, the steel is lifted manually to the bar bending area and back to the threading area through which it is lifted from with the help of tower crane. So we are proposing that the unloading area for the steel shall be kept at the rear gate so that only the manual lifting is reduced to half. Only one time the labor has to move. Also, in the slide, you can see the major area allocation of the major infrastructures at the site. Coming on to pour planning, which dealt with planning assumptions, formwork planning, concrete planning, reinforcement planning, and direct and indirect costs related to the same. The major planning assumptions were as follows. The project duration is considered 1.5 years. Pour cycle for basement 3 to ground floor is considered as 30 days, whereas pour cycle for the typical floors, which are first floor to 20th floor, is considered 15 days. For finding the reinforcement quantity, the rebar coefficient of column, beam, and slab is taken as 250, 200, and 90 kg per meter cube, respectively. Holiday for Holiday of 10 days is considered for the Holi festival. The building is divided into 5 pours: pour 1, 2, 3, 4, and 5, as seen in the image. Coming on to uh, the all 5 pours are present only till the basement level, whereas the tower area consists of only 3 pours that are 1, 2, and 3. Formwork types used at the site are conventional formwork for slab, beam, and staircase, peri-formwork system, which is a new system adopted by the contractor firm, is used for the verticals that are the column and the shear wall. Speedy formwork system is used for the retaining wall. Also, a new system, scaffolding type, is used, which is ring lock system, which is much which has major advantage on compared to the couplock system. The non-tower area has a couplock system and tower area has a ring lock system. The productivity of shuttering is calculated as per the data from the site and the area done by various number of labors, in which we can clearly see that port 2 has the lowest productivity. This was analyzed and it was inferred that as port 2 has more number of verticals, the productivity of this pore decreases. Coming on to the grade of concrete consumption, majorly M35 grade is used, which is the maximum quantity incurred in the slab and beams. The concrete is totally manufactured in the batching plant, which is at 150 meter from the site. At the foundation level, we we were uh, we were explained that at the foundation level, outside RMC was also procured. Similarly, productivity of concrete is calculated. The steel quantity calculation is done as per the reinforcement rebar coefficients of column, beam, and slab as discussed earlier in the planning assumptions. The peak quantities for concrete and reinforcement is calculated, which came up, which fall in the month of May, because from May the typical floors are going to be in full swing. Also, currently only one floor is completed per month, whereas during the typical floors, two floor would be casted in a single month. The productivity of reinforcement activity is also calculated, which, similar to the shuttering, the pour to reinforcement productivity is low because of more number of verticals. After conduction of this, direct and indirect cost for the project was conducted. For the direct cost, the reinforcement and the concrete quantities which were calculated in the pour planning were selected, were taken into consideration, and further calculation was done. As a part of indirect costs, staff salaries, PPEs, site infrastructure, etc., was calculated. As a part of the look ahead plan, the major scope of work was in which the basement 2, pour 5 of basement 2, the entire basement 1, entire ground floor, and first floor were considered. Coming on to inventory management, a total of 4 EOQ models were studied, namely classical model, model with plant shortage, model with price breaks, and reorder and safety stock. In my scope, I'm going to present model with price breaks and reorder point and safety stock. Coming on to the price break, 10 prices which were taken from the steel register at the site store were mentioned, and the lowest price of steel was 56,200 and the highest was 60,800 rupees per ton. The site being in the SEZ zone, it is exempted from taxes. Therefore, the rate of steel is low. The price break, for the price break analysis, the the numbers were put into the various formulas, and further process was done. Unit cost of steel is considered 58,000 per ton at average. 7.5 kg per square feet is considered as the steel consumption. Carrying cost is assumed to be 5% of the purchase price. And as per the analysis, the inference was that the maximum purchase price incurred is at rupees 60,800 and minimum is at 56,200 in the course of 6 months. The ordering cost is considered to be rupees 2,800 and demand is taken as 3,167 metric ton. The EOQ and the purchase price are inversely proportional to each other. As the purchase price decreases, the EOQ increases and vice versa. The lowest total cost would be incurred if the purchase price is kept rupees 56,200, and if this price remains constant, the, the cost would be incurred the lowest. Coming on to the other model of safety stock and reorder point, for the purpose of analysis, three figures of daily usage rate of steel were selected, which are 4 ton, 8 ton, and 10 ton, and their occurrence is given uh, throughout the year as according to the schedule, planning and scheduling. The lead time are taken similarly assumed to be 7, 10, and 15, and their possibility is given. The expected daily usage rate comes up to 6.96 ton per day, and expected usage during lead time is equal to 63.32 tons. The talking about the daily usage rate, their probability, lead time, and this probability are further calculated, and the possible level of usage is calculated per day, in which we can clearly see that the highlighted ones are the ones which are above the which have figure above the 63.32 ton, which is the expected usage. So the optimum safety stock as per the calculation done comes up to 16.68 ton. At this safety stock level, the carrying cost and the stock out cost is minimum, which is rupees 1,30,730. Talking about the reorder point, the average daily usage is considered 8.68, lead time is taken 9.1 days, and adding the safety stock, which is 16.68 as per the calculation done, the reorder point comes up to 94.49 ton. Therefore, we can clearly see in the graph of reorder point that the line at which 94.49 ton steel would be there. At that time, order shall be made. The lead time between two orders is 15 days. The minimum stock of steel at site would be 16.68 ton. Therefore, applying this model at no point at the site, the stock of steel would be zero. The lead time is taken as 15 days, and also the safety stock. This particular graph is calculated for 80 days for the duration from 11 December to 28 February. In this 80 days, a total of 6 reorders need to be placed, that are on the 5th, 20th, 35th, 50th, 65th, and 80th day. For the conduction of this exercise, the stockout cost for steel is considered to be 20% of the item per metric ton, and the carrying cost is considered to be 5% of the cost per metric ton. As a part of quality management exercise, the quality control laboratory was studied, in which the quality control activities, quality control laboratory layout, calibration of equipments, and test performs were studied. This particular is the quality control laboratory layout, which is present at the existing batching plant site. The site has sufficient area of quality lab along with sufficient cube curing pit. Also, sufficient staff is present at the site. Three types of quality laboratory layout critics were given, in which you can see that the weighing scale hinders the movement near the platform, so that is suggested to be kept somewhere else. The CTM shall be placed near the door which opens to the curing pit, which would ease the movement from the compression testing machine to the curing pit, and a special cupboard is suggested to keep the small equipments in place. The flowchart shows the test performed in-house as well as from outside laboratory. The equipments at sites and their quantities are presented. Also, the major four equipments which are not currently calibrated are proposed to have a calibration schedule. Sufficient equipments are present at the laboratory as per IS standards, and a quality engineer, assistant quality engineer, and two lab technicians are in charge of the quality measures at site. As a part of lean construction, value stream mapping was done. The activity selected for the same was shuttering of a shear wall. It it consisted of four layers, one panel of 900 by 1200 mm and the other panel of 600 by 1200 mm as shown in the SketchUp module. The type of waste identified were under defect, weighting, and motion. The percentage of value adding and non-value adding activities are as mentioned. The total area of the shuttering of shear wall and basement one is 446.74 square meter. The days for completion is 11 days, which is equal to 7920 minutes. Talking about our observation, the area observed was 23.75 square meter and the time taken for completion of the activity was 554.9 minutes, which is our observation time. The working hours considering 12 hours. Calculation of takt time. The current takt time is 23.36 minutes per square meter, whereas the targeted takt time in order to complete the activity of shuttering of all the shear walls should be 17.72. Therefore, there is a need to decrease the time by 5.64 minutes per square meter. Talking about some type of waste like chipping hard concrete with chisel from surface, stamping with corner connector to remove the hard concrete, wiping with jute cloth to remove the dust, and mobilization of shuttering oil were some of the many waste which were identified. In order to reduce their time, lean tool application shall be done. Lean tools like continuous flow, 5S, JIT, Kanban, just in time, Pokayoke shall be implemented, and the description is as given. For the same, future state mapping is done. The comparison of current and future state is given as in the graph. The comparison of takt time is also shown, in which the achieved takt time is 14.94. The targeted takt time was 17.72. Therefore, there is a reduction of 63.95% in non-value adding time after the application of lean tools. Therefore, there is a reduction of 36.05% in the cycle time after the application of lean tool. Therefore, it is inferred that by efficiently applying the lean tools in the construction, we can eliminate the waste and therefore the work can be done and completed timely with greater quality. Concluding my presentation, I would like to give you a quick brief of the learning outcomes from the deliverables explained. Pre-construction activities are very important and they need to be looked upon seriously and critically. This would help to function the work smoothly at the time of construction. Site layout visualization gave us a chance to explore the Revit software and incur knowledge about various facilities and their consideration. As a part of the scope of contractor is RCC core and shell, the spore planning plays a major role. Proper planning will lead to completing the project in time and with full expectations. The inventory management helps to figure out the stock that shall be kept at site along with the planning of ordering dates. This helps to keep the cost in place. The quality control laboratory is one of the important aspects in order to achieve the required level of quality in work. Lean construction, which is an upcoming concept, is very useful to have the best quality uh, and achieving the most effective outcome. The lean tools can be skillfully applied, which would help to reduce the waste incurred at construction sites. I'm thankful to present my work in front of you. Once again, thank you.